Hi guys. So as I said yesterday, I'd be doing a video of just a harder, well, not even harder, but just a HSC style question on these lines of best fit. So the first example I have here, again, you can pause the video, start copying down the questions, or just go straight to your lesson plan. We've got heights of people versus the foot lengths of them. Okay, so the first thing said put in a scatter plot. So I've just gone ahead and done that, okay, because that's nothing new. Again, your axes can be different to mine. I've gone basically straight off their data, okay. The height being your dependent your independent, and your foot length being your dependent, depending on your height. And you can see my scale there, so I'm quite, like I've mentioned before, zoomed in, okay? So I needed to be taking that into consideration when I'm talking about my associations. Okay, so then it's asking me to now describe my associations. So I'm keeping in mind that I am zoomed in, but even then, I'm zoomed in. I would not call this strong, okay? It's still not strong. But what I would call this is moderate, okay? It's not weak because, I keep saying it, but I'm zoomed in, all right? So they're going to be a bit further apart the more closer I look at the data. And imagine, like, zooming out. This is going to be what, like, I'd call it moderate. I'd call it positive and linear because it's in that straight line direction. Okay, now it says by eye, draw your line of best fit. So by eye, remember, it's the same amount of dots above and below. So what have we got here? We've got 1, 2, 3, 4, 5, 6 dots, which means I want to try. Okay, notice my word there. I'm going to try and draw this line with 3 above and 3 below. Okay, I'm not making any promises, but I'm going to do the best I can. And I can see that if I did go from here, oh, hang on, now I have 7, don't I? So what you want to do again, remember you want to try and make that distance between each dot in your line as small as possible. So I could put my line through that point there, and then I still have 3 above and 3 below, okay? So there's my line of best fit, and again, remember it's an estimation because you don't actually know what the equation of that line is, and that's when we look at your least line of squares of best fit. I can never say that right, but you know what I mean. So I've drawn my line of best fit by eye. Now it says I need to determine my Pearson's correlation coefficient. So this is where you go back to that little summary I made. It's on Compass on how to do Pearson's correlation coefficient on your calculator. Putting all those values into your calculator, I'm going to pause the video and tell you what I get. Alright, putting all those in, I got an answer, and I'm going to put the entire calculator screen on just so you can see. 0.6920121,582. Alright, now it says describe what this means. So what that means is, well, looking at the table, okay, think about each quarter of your decimal point. Where does this fit? So it's basically 0.7, which is in fact in that moderate. So it's just under, so remember about 0.75 is and above is where you go into the strong, okay? So, next one, determine the equation of the least squares line of best fit. Now again, this is where you're going to pause your video, go to yesterday's lesson and look at that summary and put it in. The thing is though, if you already have all this data in your calculator, you don't have to re-input it. If you go straight to shift and then 1 again, all that data is still in your calculator because you haven't put any new data in it, you haven't turned off your calculator, it's still in there. So when you press shift 1, if you go back to your 5, now just press 1. Press equals. Now that's told me my A value. So my A value is equal to negative 8.354409,318. Clear it again. Shift statistics 5. Now I go to 2 to find my B value. Press equals. And my B value is equal to 0.2204658,902. Now, Remember again from the lesson yesterday, the b value, confusingly enough, isn't the y-intercept. They swap it around because remember the equation in your line of best fit, they write it like this, which is very frustrating, but we just need to remember that. Which means the equation of this line, I'll do it to 2 decimal places, is 22x minus 8.35. So that there is the equation of least line squares of best fit. Okay. Now they want us to sketch this on the graph. Remember, to sketch this on the graph, I only need 2 points. So I draw up my little table of values. And I only need to plot 2 points. So I'm just going to pick 2 x values that are nice on my graph, pretty far apart, but not too far apart. So what if I did one at 150 and 170? Okay, that's either end of my axis there. And it doesn't matter which ones you do. And I'm going to put these into my calculator and write what I get when I substitute, and I'll just show you in case you're not sure, substituting this x value in to my equation where x is, and getting my answer and writing it to the corresponding y value. Alright, and that's what I got on my calculator, and I just subbed it into this equation, so they're the rounded values, okay? Alright, and now I just have to plot them on and join them together on my line. So I have the point 150 and then 24.7, say. 150, 24.7, so nearly 25. So I'd be looking at about here. And then 170, 29. 170, 29. There's my 2 points, and now all I'm going to do is draw my new line between those 2 points. Okay, so I'll do it as best as possible, and that's good enough. Alright, and I'll just make that a different color. So my least squares line of best fit is now in red, and again it is quite close to what I did by eye. Alright, so then it says, what is the expected foot length of a student given their height is 180? This is where I use my least squares line of best fit. So 180, think about where that would be on your graph. Well, I've got 175, 180. Sorry, I'm a bit shaky, I've just had a coffee. Let me just fix that. 180. Alright, so I'm just going to follow that up and increase it all the way, and also increase my least squares line until we find again that point of intersection. And again I've gone outside a bit, but I'm going to say, let's say that the next line there would be, what could we say that is? 30.5. Okay, because they're going up by halves each one, so I could say a foot length of 30.5 centimeters. So there I have it. Okay, the next example is same idea, but it's just slightly different this time. Okay, this time it's given you the graph. It hasn't really given you any context behind this graph, so let's just say that this was shop sales in the day, depending on the temperature. So you can see here when it's very cold, there's not as many sales, and it's sort of increasing in quite a strong trend. It says to determine the gradient of this line. So it's just going back to your linear relationships. To find the gradient of any line from a graph, we're just going to do rise over run. So don't overthink it. Be careful with your rise over run here. Remember, with rise over run, you want to find 2 points you know and draw the triangle between them. So let's think about 2 points that I can estimate as best as possible. So what have I got? There's not much given to me here. We could do here, that's the point 16, and what if these are going up by, let's say 320? Let's find another point. We could do this one here, even, that exact point. And let's say that's 22. And it's gone up 520. Alright, so now I'm going to draw my little right angle triangle between these values. And remember, it's the same thing as your height of your triangle over the length of the triangle. Okay, so what have I got? The height between those two values, okay? So I've gone, let's look at, I've gone up 320 to get to this point, and then it goes up to 520, which means it has a height of 200 on that triangle. Now the run has gone from 16 across to 22. So then I have a run of 6. So now that's my gradient. I can simplify that. 200 divided by 6 is not the nicest number. What if I simplified it to just a 33 1/3, or we'll just round it to 2 decimal places. Let's do 33.33. So there's my gradient, okay? Alright, so m equals 33 1/3 or 33.33, however you want to have it. Okay. Explain the meaning of the gradient in the context of this data. What a great question, okay? It's a great question because it's really testing your knowledge. So stop for a moment and think about what it would be. Alright, basically remember, it's the rate that it's changing. And they want to see that you can relate gradient to the rate that something is changing. So always be mindful to use that, and make a note in your book or on your notes. When you have to describe the context of a gradient, it's the rate it's changing. Okay, so I want to be a bit more specific, and I'm going to type this just because it's a bit neater. So explain the meaning of the gradient. Okay, so I said the gradient is representing the sales price increase as the temperature increases, okay? So that's nice and broad, but then I can be more specific and say it is evident that for every temperature degree increase, sales are increasing by approximately $33. So you're not just showing that you understand what gradient is, you're showing, in fact, how you can understand this particular gradient. So then, it says determine the equation of the line of best fit. Now, the equation of any line is in the form y equals mx plus b, remember. We already know m. All we need to do is find b, okay? So b, remember, is your y-intercept. So you could do this by an estimation, all right? And you could just extend your line through. However, I'd recommend doing this precisely. Okay, so how can we do this precisely? Well, again, you can't do this completely exact because they haven't given us a grid that's accurate enough. However, I know that I said the point 16 to 320 lies on this line. So I know that when an x value is this, a y value is this. I know my gradient is 33.33. So I could sub all those values in. 320 is equal to my gradient, 33.33, x, which, I do know the x value, at 16, plus b. So b is the part that we don't know. And again, we can estimate that extension of that line, but we're working it out properly here. So now I'm going to have 33.33 multiplying by 16. So 320 is equal to 533.28 plus b. Rearranging that equation, I'm going to get 320 minus 533.28 equals b. Alright, now that gives me negative 213.28. And you're thinking, hang on, miss, but how can the y-intercept be that when it looks like it is this? But that's not the y-intercept, okay? The y-intercept is when, oops, sorry about that, this line has a 0x value, okay? And we're at 10, so we're going to have to go down quite a few, and you would have to keep extending that line further and further and further and further until you saw what it was when it was at the origin at 0. So it's definitely important to know how to just sub in x and y with your gradient, rearrange to find b. Okay, so then therefore the equation of the line is equal to 33.33x minus 213.28. Tough question, okay, but it's expected that you know how to do that. Alright guys, I will upload this video and the lesson plan onto Compass.